Hi friends, Naji here. Welcome to my YouTube channel. We are continuing a discussion with LangGraph, and if you are following along with me, and we have discussed a conditional LangGraph in which we explain how the conditional LangGraph is works, right? So we explained about this particular graph and we discussed how we build this. So if you are looking on that, we can see that we have a node 1 is there, and based on some conditions it will go to node 2 and it will go to the node 3. Okay, so just have a look on the coding part. We can see that we are adding a conditional edge, and here we are passing a method called conditional node, and just go and check this node. Here we can see we are getting some user input. Based on the yes or no, we are going to node 2 and we are going to node 3. So this is actually working perfectly, but there are some scenarios in which when we move from one node, so we have to update our state. Okay, so conditional edges or conditional method or conditional LangGraph which does not provide an option to update our state. Okay, we can redirect to another node, but we will not able to update the state. So that is how the LangGraph has introduced an object called the command. So in which we will able to redirect to a node, or we can, it's just like a go to statement. We can go to a node and we can also able to update our state. Okay, we'll see how this works. So for that we can do some imports. So let me import random, and I can also import from typing extensions. We can import the type dict, and we can import literal, and from LangGraph.graph I can import the state graph, I can import the start, I can import the end. Okay, now from LangGraph graph.types we can import the command kind of type. Okay, now we can define a state. So this is our state. So this state is a type dict, right? And I can have a property like few, that is string. Now let's define a node that is called the node A. Okay, here I can mention our state. Okay, then this is a conditional node or command based node. Here we can mention the command. Okay, so the command, and the return type is a command, and literal, in which we will go to node B, and we will go to node C. Okay, now we can print. We can say that called A to understand that we are in node A. Now here we can define a value. Okay, and in that value what we will do, we can choose a random choice. I am saying that A or B, and if you can say that if value equal to A, then go to, I can say that you go to node B. Okay, else I can say that go to node C. So based on some condition or some random value, we are defining where we need to go. Okay, so this is almost same with our conditional graph, LangGraph. So here I can define a command. Okay, so this is the difference. Here I can do a update. Okay, so update can be, I can update foo. Okay, and foo can be updated with value. Okay, the value will be A or B. Okay, so now we have the command is ready. Now I need to specifically say that where to go. Now I can say that go to the go to. So it will go to B or it will go to C. Now let me execute this. So we have our node is there. Now we can define node B, and node C also we can define. Okay, so this is my node B. I can specifically say that state. Okay, here I can say print called B to ensure that we are in B, and here I can return what is need to be returned. So here we will be returning the foo. Then I am getting the state, current state plus I am updating B. Similar way we can import node C, or we can do the node C. Here I can mention state. Okay, the same copy. Here I can say that called C now. Now just return foo state. Okay, what is our state? Take the foo, then C. Okay, so now we are ready with our node. Now we can start building on that. Okay, so let me add a couple more cells. Now I can create a builder. Builder will be state graph. It will be state. I can build a add.edge. Okay, so we will have a start. From the start we will go to node A. So node A is something like here, right? So first we will go to node A. Now we can define some node. Add a node. You can say that node A, builder dot add a node. You can say node B, builder node add node. You can say node C. Okay, node A is already exists, so this will be node B. Now we can compile the builder. Builder dot compile. Now let me draw this diagram that we have created, so you will get a clear idea about how this looks like. I can have a image. Okay, now let me print it. Okay, so to print it I can have a graph dot, can take get graph, then draw image. See how this looks like. So we will have a start, we will have a node A, and we will have a node B. Cool. Now we can execute it. Graph dot invoke. We can call the invoke. Here I can pass foo as empty. We'll see how this will work. Let me execute it. So here it is first go to the called A, and then it is going to B. Okay, so once it is B, we are updating the state. We are in a B, then we are updating the value C. Okay, so if you look on that, first it is called A, then it is C, right? So once it's C, then it will append the C with that, and it will have a state of foo. So initially the state will be A. Sorry, not A. It's B because we selected the C, right? So initially it will be C. Okay, so we are updating the foo with the value. So since the person is randomly selected the C, then it is going to the C, and we will be updating the foo as C. Then within the C we are appending the C, right? So that is how we are getting foo as B and C. Okay, so in this way we will easily able to update our state when we conditionally move from one node to another node. Okay, so that is all about in this video. So in our next video we can discuss about how can we update the conditional update can be happen in the subgraph. Okay, so please do like and subscribe. Have a nice day. Bye bye.